My name is Fabrizio. You can find me on Twitter. You can find my website. Maybe later on there will be the slides and so on. I'm lead software developer at Greta Starks. It's an app for subtitles and audio content for disabled people. And I joined roughly 6 months ago. Previously worked at a Rocket Internet, a Spriker, developing PHP for many years, too many maybe. And when I joined Greta and Starks, I was asked to take the legacy application that they have on a hosted server, and because the app is growing and the regions, the countries where we want to go are growing, they asked me to actually do the whole AWS deployment. We decided with the team of 4 or 5 other developers, sorry, to migrate to a new Symfony application, Symfony 4.3, and of course to ensure best practices, security, and so on. That sometimes as developers we don't do. So what I did was the first thing I did is actually I took the legacy application and I started like literally removing everything that could be a security problem, that could lead also to downtime or like a slowness when you want to have a test server, a development environment. So the first thing was like removing all the passwords, all the tokens, and put it in M files, as Symfony does. I clean up all the data from like literally I had some dumps from like pre-production environment. I anonymized everything. I just kept like 5 users, 5 admin users, 10 movies with their files, and also all the medias, because you can't put on GitHub like 10 gigabytes of images and so on. So, and I divided them into like different repositories. So that came in handy after when I had to put on AWS. So I had the repository with like 100 images, logos, and other stuff, and the poster, and also the media files we use, and also for the database. So it's easier, and that I've been able in the last 6 months to onboard another 3 developers, and they were practically operative from day one. They had the machine like in 1 hour, 2 hours, they could install it. Another thing I did is to update to the latest version of PHP, check everything, PHP, like the security version, MySQL, latest version of the framework. So I took all like the Symfony 4.3, see what is the long time support, and yeah, also the Composer, because sometimes also Composer needs to be cleaned up, it needs to be taken care of. Sometimes we have dev packages into Composer and so on, so that's not good. And another thing, and this keep it in mind for if you go to AWS, is like the cache and temp files, especially if they contain sessions or other data that you might want in the next machine when you replicate it. It cannot be on the file system. I mean, it could potentially be, but then it becomes more complicated. You might have rights issues on mounted folders. It's easier to move it to Redis, to database, or to any other storage you want. The second step was to actually use Docker. For who doesn't know what is Docker, it's like virtual machine with the configuration file. It's faster. Surely it's faster the development because it's all configuration based. So I'm sure I give you the machine, you run Docker Compose, and it's a reproducible environment. I struggle sometimes to find the right packages for setting up a PHP application. The best one I found are these Bitnami, Nginx, Bitnami PHP. And Bitnami has like Redis, has Laravel, has other famous PHP-based application or utilities. And another one was actually the SMTP, because this machine don't come with an SMTP server, so you cannot send emails from your application if you don't have one of this. And the reason why I use the Bitnami, and in this case also MySQL for the official one, is because they are highly configuration based. So you can configure everything. You can configure your Nginx files. You can configure, like, for example, for MySQL, you can configure if you have like some previous SQL and you want to insert in the database when you spin up the machine, then automatically there is a folder where you can put your SQL files. And I learned few lessons that came in handy after. One was to use Docker Hub because you have all the images there. Is the port mapping, take care. The port mapping is very useful when you develop because you want to connect to MySQL, you want to connect to Redis, but you have to disable later when you go like staging and production because machines already connect inside, so they can communicate with their network bridge. As I said, you need an SMTP server. I also use mounted volumes. So, for example, both applications, Legacy and new, the Symfony one, use Composer. So I didn't have like two folders for it. It's just like you configure mounted volumes. I say this is my Composer vendor folder, and I avoided so far, and I will try to keep it like that. Custom Docker images, because if you have this and then you do AWS, as we will see in a few minutes, then you will have to compile your own image and tag it, and then put in your the Elastic container, and that the complexity that you don't need right now. Most likely, unless you have really specific stuff, you don't need it. And why you don't need it? Because when you open AWS, you see this, and this is actually half of the page. You could scroll down, and the number of services, especially, I mean, even as a PHP developer for many years, I've worked with the Linux, I've worked with the deployments and tools. But when you have to do by yourself, you don't have the DevOps colleague or someone more experienced. Like you open this, you're kind of scared, so you don't need to get overwhelmed like immediately. And another thing, you need the credit card. It seems stupid to say, but for example, if you're doing your own project, you have free tiers for the nano version of the machine and so on. That is good for some months. But if it's work environment, just ask a credit card, $100 per month, $200 per month, because you need to have, you have a memory limit. Some services don't spin up if they don't have more than, I don't know, half a gigabyte. Like, so they might crash immediately. So yeah, you need a credit card to set up a credit card. The first thing you need to do is having your EC2 machine. So EC2 is your instance, is like virtual machine, and the thing I did was to actually create a staging first. I mean, I didn't know at that time. I figured it out on the way. And so you just need to pick this optimized Linux to AMI, because this is the one that allows you, if you choose wrong, you have to redo from scratch. Allows you to have ECS, scaling deployment and so on. And without this, you can't. There is also Windows version if you want, but I wouldn't recommend. And as I said, for example, in this case, the micro version, it's for free, but I chose to stick to the medium because it's a work environment, so all the services had to work. Why is starting with staging? Because it's a base for production. So the first thing is like you create it, you need to set the ports, you need to set, this is really important, you need to set the YAM roles. And the YAM roles is like, they define which role can access what. So you can decide, for example, if a machine needs S3 buckets access or in the future other services, you just append to the role. And you need to create one, and in this case, you need exactly the Amazon S3, in this case, full access, and you need it, otherwise your machine won't be able to mount the S3 buckets or whatever other service you want. So it's a way to manage rights without sharing passwords. Also, be careful at this point. You will need also, you will download during this process of creating the machine, you will download a PAM certificate that is specific for that machine, and if you lose it, you cannot access the machine with SSH. So keep it a copy on your USB key and so on, and this is really important. Then another thing I did was when I got USSH in the machine, I said, okay, now I need to put my application. So the first thing is like, whenever you are doing this process, you want to be sure that at one point your application, your Docker application works. So the first thing, you clone your repository with GitHub, in my case it's GitHub, and do not store credentials. So just you can create a token like a password and you just use it. I check out the repositories and I save every file I need, like env files and so on, into the home folder of a EC2 user. But then the application is an OPT. Some are symlink or a copied folder. That's just because I figured that OPT is like the folder where you usually put like this kind of vendor stuff. But you want your own copy in EC2, so you can have like some log folders, some folders there. So once you check out these folders, and then you do your own mapping in the app folder, then you need to have the S3 buckets, or at least in my case, we need it because we deal with media files, so we need the storage, and S3 is like an infinite storage. And we started right away with at least 3 buckets. Now I think there are 5. One is for the storage of the media files. One is for the logging. So you can tell, as you set a new service, it will tell you where do you want to store the logging, and you can say, I want to store in this bucket. And one is for deployment. So the tool for deployment, I will see later, also needs a bucket. This is the Git project, GitHub project file system user space for mounting S3 buckets. And you have to remember to remount at reboot. So you try, but you literally need to do cron tab -E, and then you remount. There is a command you will find online that you can remount, otherwise it's not there. The second step was, okay, I had my application, everything was working, but I had to configure I had to find out what was the Docker of AWS, and this is ECS. ECS works like this. It's like there is a service. How is the pointer here? So actually you start creating this task definition that it's your Docker compose. Then you create a service and you tell the service which task to which machine that you don't have it registered yet to execute. So ECS will practically run Docker for you on that machine with the task definition that you have here, and hopefully with the file that you put on the machine. So you create this task, and then what happens is it takes care that, for example, you can say, I want at least one instance always up, and if an instance goes down, crash, whatever, it gets immediately respin up again, and that's because the machine has an ECS agent. And as we can see here, what you need to do, as I said, is map this task to that is your Docker compose, but it's visually. There is also JSON version, but what you can do is like doing visually. First thing, you need to create the shared mounts. These are the folders in your EC2. So you say, okay, my content folder is under OPT app content. My repository for Symfony is in this other folder, and so on. And because then when you create, you add the different services like PHP and Nginx, it will ask you the same mapping of the mounted folder and Docker file. You need to set up the minimum and max for the memory and the CPU units. This is mapped to what we saw before when you say the version T2 medium, 4 gigabytes and so on. And the minimum memory should be the sum of all the minimum memories for all the services cannot exceed the maximum memory you have on the machine, of course. You should choose network bridge. You should set up almost, that's what I did, almost all the services are non-essential, because it's you need to think like if a service doesn't go up, all the services go down, like everything goes down. And in this case, is the database, which is the single source of truth. So it can happen that not Redis goes down, that's fine. But if the database goes down, everything goes down. You have to remember to do the port mapping or not do it in case you don't need it. And to add the networking link between machines. So you want, for example, the PHP and Nginx instance to see Redis, to know what is the name, the internal name you use for MySQL. Then you create this task, and this task is version, so don't get scared when you save it. You see number 1, number 2, and so on. And it's a good thing. You can also delete the old ones when you are sure that yours works. You can take the JSON and save your repository. After you have done this, you need to install the ECS agent. That's because then the ECS cluster and service will automatically know how to do it. And they know because the ECS agent in this specific file you have to tell the name of the cluster. So when you will create the cluster, the service associated with the task, then you put the same name here, and then the service will know, okay, this is a machine associated to this, and I can spin up the agent. With this, now when I arrived at this point, I had my machine up and running. It took me a while. I mean, I think I arrived at task number 47. And then my service was working, everything was working, but I wanted to deploy. So I used the CodePipeline. CodePipeline as part for the source code that I ignore completely because I use GitHub. And then he has a part for the code build and one for code deploy. How does this work? In practically, the code build takes the file from your GitHub. It does a zip file using this build spec YAML. Is practically just a specification for like a Linux machine, and it generates another zip file that goes in code deploy. And code deploy has this very important file called upspec that tells where to copy. It unzips the files, and then upspec has this hooks. So it practically say after I downloaded the artifact or before I install I spin up the application to do some task. And this is really good because so it unloads the zip files, it unzips the file, and you can tell to copy the different files from your repository into your system, into your EC2 machine. Yeah, so the problem is where your website is visible. In this case, you have your EC2 instance, and EC2 instance usually has a private and a public IP. But you don't want that. You don't want to tell the people this is the IP. So what I found out is if you register or transfer your domain with the Route 53, you then can configure everything, SSL certificate. You can configure subdomains all from one dashboard without relying on other hosts or spending days trying to figure it out. So I recommend to register or move your domain to Route 53. And then you set up an elastic IP address that is a public address you associate with the machine, so nobody knows, shouldn't know the public address of the machine, at least only this interface. And then you map your staging, myapp.com, whatever, to this IP. And then you need to allow only HTTP and HTTPS. The SSH is only for the private, like something like it's another IP address, but it's not publicly displayable. And as I said, from here you can also add your SSL certificate. If you don't have one, you can pay $5 and you buy, because that will come in handy later also for production. Yeah, what about production? So once I finished staging, I was super happy, and I was like kind of feel sad because I was like I have to do again for production. Because in production, staging is okay that some things, it's like simpler, like even the deployment, but in production, you want a system that in the future will scale and allow you to have multiple instances and so on. So I started with a staging machine because I had it. So you can copy it. You do a snapshot and then you copy. And then there is an internal name, like an attribute you need to change. There is another machine. You need to download the PEM certificate. Again, for that machine, you need to log in inside and change that cluster name that we said before, and also to change all the environment files, like passwords, or for example, if the data source is another database or is a service you don't want. Once you have this machine set up for production, you need to shut it down. Do not terminate. Otherwise, if you terminate, it's going to be like destroyed. Everything's going to be deleted. And then you create a launch template from it. And that's very important because a launch template is a blueprint. It's practically, whenever we will see later, it practically does a copy. It uses exactly the same PEM certificate. It has all the configuration there. And that's also why I say shut it down, because you need it to have it there, like sleeping, because when you want to update the CS agent or you want to add a new service, you need to work on a working version. So you have this sleeping one, and then you create a new launch template. How do you use this launch template? You practically, this is kind of complicated. You practically, with the idea that you had before, like my idea actually was to have like this blue-green deployment, to have two instances like switched. So you need to create a load balancer. The load balancer, ideally should like switch machines, but to do that, they need to belong to the same target group. And then you need another service called autoscaling that use that launch template and spin up how many machines you want. In my case, it's a preferred one, maximum two, because at one point they can be two at the same time. And then you need to assign an elastic IP to the load balancer. And finally, you can assign your production URL to the elastic IP. So it's kind of not very easy. It takes time to figure out all the pieces, how they work. And the nice thing about the autoscaling is actually really checks that if there are no machines running, it spin up another machine, another EC2 instance from that launch template. The last part is actually to put all together to have another code pipeline, another pipeline, CodePipeline, where you actually, in this case, you will have to recreate all these ECS tasks. You just copy, and you need to change the name, cluster production, something. And you want to create this blue-green deployment, and the blue-green deployment is in CodePipeline is slightly more complex, because the normal deployment we saw before in the CodePipeline was like, whenever a machine gets deployed, has only a certain amount of steps of hooks. But actually, when you do a blue-green deployment, the machine, like the traffic gets moved from one machine to another. So the auto-scaling gets duplicated. You spin up a machine, it registers to the target group, it registers to everything, to the cluster, and then it starts redirecting the traffic. And when the traffic is finished, you need to have practically gets shut down. And the very important part here is the up-spec hooks, because here you have all the steps, including this traffic one that before you didn't have. And this really comes in handy, because I had a bug for which practically the machine wasn't killed. I mean, it was still was not registering from the target group of the load balancer, so it was still pending there, although it didn't have any traffic. So I actually, in this part, I said, when you don't have traffic anymore, just kill the machine, just shut down. So literally, the command is shut down. So the machine will disappear from the target group, it could continue, and you have your new machine. And I think that's everything. Part to do is like monitoring, Travis CI, Kibana, but yeah, this is maybe for the next talk. Thanks very, very much.
Nowadays, everyone uses Facebook, so you can have a chatbot. You're gonna say, "I'm in the airport of Amsterdam." Context is a concept that already is, for example, in Google Home, but it becomes very useful when you want to build conversations.